So what we are going to say today, well, welcome to class 5 first, and good evening. And we are going to go through some tools that will help you in your pipelines. So Denise, I think Denise asked it, what kind of scripts you're talking about? What are you expecting in terms of scripts exactly? What should we do with these scripts? So hopefully today things will be clearer in terms of what type of scripts we are expecting for project 1 and what type of scripts we actually use in our daily routine at enterprises. We are going to see these three first tools that will help us to be consistent in our pipelines and to share with other developers the pipeline steps. Make, Docker Compose, and 3Musketeers, which is not a tool, but an approach that uses Make, Docker Compose, and Docker. And then Kyle will lecture about CI/CD, continuous integration and deployment, and how you can achieve it using GitHub Actions. So let's get started. Today, I'll take an approach more practical because these are tools and the tools are bloody simple, but the way you use it and the way you use them together, that's what actually has the power to help us achieve what we want to achieve. So let's start with Make. So Make is a tool available in most of Unix systems. Well, you can add it, you can just install it using any package manager like APK, apt-get. It's just an executable that helps you to execute some targets, some steps that can be scripts, for example. So I think it's one of the tools that's better to show how it works than to keep talking about documentation and things like that. So if you go right now to your Mac, Linux, probably you'll have Make command available to you. If you run it, you see it will show no target. So it's looking for a target. So as I said, Make will help us to execute scripts or steps in an organized way. So let's suppose I want to run this echo hello world. Then I want to run, following this, a goodbye message. So I have a complex script here with 2 lines with 2 echoes. What you could do using Make to organize this, instead of having 2, 10, 15, 50 lines of code, you can make it easier. Just let me create a folder here. You can create a definition for this target in a file called the make file. This make file is what the make command will look for when it's looking for targets. So let's create 2 targets. One target to say hello and another target to say goodbye, right? So I'm creating here a new make file. So I'll create a new target here. A target is just like a label you create, then you indent, and you include your commands or the scripts or any executable or application that you want to run. Here, if I say echo hello world, as we did before, then I add a by target and say goodbye, echo goodbye, and just save this file, right? I have this file there. Now, if I run make, it's going to execute the first target in my make file. What's the first target here? Hello, right? So it started looking for targets. It found the first one and executed what was inside of it, right? But I can be more explicit and just say make hello. It just executed the script that was there. I can say make by. It shows the command, and this is the standard out. This is the output. If we don't want to show the command you're executing here because it's going to be 2 variables, you can always check the make file specification to see the details of everything that you might use here. But you can add just at before echo, and it will suppress the command, but not the standard out. So make, and now I have just hello world. If I say make by, goodbye, right? Is everything all right? Now, going down a little bit, let's talk about dependencies. Let's say I'd like to say goodbye, but for saying goodbye, first I need to say hello, right? With Makefile, it's easy to define these dependencies. You can just in front of a target say that to execute the by target, you want to execute the hello target first. So you just include hello here. If you have more targets than that, more dependency targets, you can just keep adding them here. Space separated. So I'm going to say this by now that depends on hello, and just call by, make by, right? So you can see that the by target, it's calling hello first. It's executing to the end the hello first. If the hello target doesn't fail, it will just go on and execute the by target. So can you see the start of something similar to a pipeline here? Can you see different steps defined in a way that you can say what comes first and what are the dependencies? One common thing that we do when we create make targets is also specifying an all target, because as you saw, make targets, make will look for the first target in your make file. So to have more control over the execution of the first target, you can put all as the first target and just force it to execute everything that you want to execute by default. So hello and bye. Here, hello will be duplicated, right? So when I run make, only make without targets, it's going to call all target. So hello and goodbye. Targets can also depend on files, and that's very useful. So let's say that for executing hello, we depend on this file called myname.txt. So you just specify a file. Here you could put a path if you wanted to. You could say output my name or something like that. Or even better, in the make files, you can have variables. So you could say, you could hold this value in a variable. Now, if you want to run hello, it will complain saying this make target depends on my name.txt that I don't have here in my current folder, right? So if I just create this file, it can be an empty file here. And try to run make hello again. You can see it executes. So it's another type of dependency, right? So to avoid confusion between targets and files, you can use this .funny clause that's basically going to say, give precedence to the target instead of a file or anything else. So removing this my name txt, coming back to my make file, let's create a new target. I don't know if it can have dots in the name, but let's try it. And we'll say funny. Not sure if this .txt will work, but let's see. So now I deleted my name file. Yeah, that worked. So what I'm saying here is this should be treated as a target, not as a file. So it's looking for the target with this this name. Usually we put funny to almost all targets because we don't want to confuse a target with a file or another dependency. We can have a target here called output, then we have a folder output, so you need to distinguish between them. So you can just create a space separated list here with all your funny targets.
Can I just make a comment, Dennis?
Sure.
This whole thing with make and files, it's because make originally was made for compiling binaries and applications. Well, it wasn't for automation in DevOps. Make is probably 50 years old. I don't even know, but it's one of the first Unix tools around. So that's why it has these old features that you need to tell make that you are not using for files. You just want to use as a shortcut for commands.
Nice. Thank you. So we could specify targets. We wrote some scripts inside this make file. We specified dependencies and even a variable here. So let's talk about variables. Let's say I have a variable here called name. So you're going to say hello to someone, right? So there's this syntax for a variable that says, if it was not passed in as an argument, just use this value here as default. So name is going to be default to nobody unless I override it. So let's just change a little bit our hello world to use the name here. Right? Let's save it. make hello. So it's saying hello word, nobody, because I didn't pass this variable, right? Just use it the default value. One way of passing this variable can just set it before calling the command, the make target. So I can say make name equals Dennis, make hello, then you have hello world Dennis, right? Let me remove this dependency here because it is printing trash. And of course, you can also export these values if you need to. Should be environment variables. So you could export name if you wanted to. Going forward, looking at the left side of the screen, well, we talked about this, right? We may have several targets. A target may have several commands under it. But think a little bit about this for a minute. Do we really want to have 300 lines of script on a single make file? Or it would be better to split it in several files in a way that we can easily see the execution steps in the make file. Then if you want to know more details about the script, we can open the script file and look at it, right? So we want to make these steps inside the target simple to read. So we are going to keep it to a minimum, right? We'll talk about this in a minute in the 3Musketeers approach. Another thing, you can always run make with several targets. So what are my targets here? I forgot. So we have all, hello, bye, and my name. So you can say make my name goodbye. I mean, bye target, then hello.
It's my
name.txt. Yeah. So when you call make, you can pass several targets for it to execute. Hello failed. Bye. Nothing to be done for hello because it has already been executed because bye called it. So that's another reason why they all didn't duplicate the hello word and name. If you notice, when I called make all, there's just one hello word and one goodbye. Shouldn't be two instead of one, because in bye, I say as dependency, call hello, or hello needs to be executed. And then I call hello, right? In fact, this dependency, I think the right way of reading this is make sure that this target was executed before executing this. It's not exactly a chain of always call hello when I call bye. It's not like a chain, but it's like a dependency check. Did hello execute before bye? If no, it will execute it. If so, it won't execute it again. So that's why when we ran make all, you can see just a hello word, nobody, then goodbye. When it came to execute bye, hello word, hello was already executed, right? It didn't call it again. And that's it. Any questions up to this point, guys? Are you getting how this works?
Just a question about the application of this make. So we create these files to automatically be executed, but how do we actually use it, apply it in, I don't know, Terraform? How do we use it? What is the application of the work?
Good question. Good question. Great question. It's going to be clearer in some minutes, but you remember when you did Terraform plan?
Yeah.
Well, it's not going to run here because I don't have any TF files. You did Terraform plan, you did Terraform apply. You've executed a lot of commands in the command line already, right?
Yeah.
To complete the exercises. You can organize the same commands that you needed to execute for exercise as a target.
Mm-hmm.
So you could say here that you want to call Terraform plan after the hello world plus name. And after that, you want to call Terraform apply. The commands will not work because I don't have Terraform files, but just for you to see the chain of this call, it's just like a script, a set of commands that will execute in, well, from top to bottom, but it may have logic here. You can have if statements here, while loops, and so on. So if I call make hello now, you can see it called the Terraform plan, and it failed when it called Terraform plan. So it halted, and it didn't call Terraform apply.
Yeah.
Right?
Okay, let's say you want to continue where you, because you just run the Terraform plan. Let's say you fix it, and then you need to go back to that specific point. Is that possible, or it will run everything again?
That's a script, right? A script runs sequentially. So if it fails at a point, you need to understand what happened. And you should write scripts in a way that if they fail, they undo any change that happened, or they are at least easy to troubleshoot.
Mm-hmm.
There are ways of ignoring errors, but you should consider if it's really necessary, right? You could say, just ignore the output of this. So you can say or true. It's just logic here using bash. Or you can say, I think it's minus. Makefile has a syntax for it. I think it's minus. Let's see. Let's see if it passes the Terraform plan command at least.
Yeah. Yeah.
It passed.
Mm-hmm.
But my output here is still different than 0. It's 2. So this program executed with error. It didn't exit nicely. If you want to ignore the next one, you could as well. And probably it will finish with status 0. So make hello. So errors, but all of them ignored.
Mm-hmm.
And your status is 0. So yeah, there are ways of ignoring errors. But yeah, it depends on the script you're doing. They should be small enough to stop when something breaks and easy for a developer to troubleshoot and fix it.
Yeah, okay, thanks.
Yeah. Okay.
Can I create a real make file? For example, I want to create EC2 script in Terraform. So can I like use a file as a scratch and create one with just replacing my variables on that and create a new one? Did you get my question?
No, exactly. That's exactly what we are going to do today in some minutes. So
all right,
just one last example to not hold too much on this, but do you remember AWS S3LS?
Yep.
And just run it here. It's running on bash by default. If I execute make hello, it will execute the AWS CLI command that I put there.
Nice bucket
And,
name.
sorry?
Nice bucket name.
Tests, man, tests. Well, yeah, that's what we are going to do, Adriana. You're going to see a way of organizing the code structure, and it's called the 3Musketeers. We're going to see it in some minutes. I think I need to go on because we have Docker Compose and these 3Musketeers. They are more interesting. So we talked about dependencies, variables, right? With funny targets. There are some other examples in the class content. Please take a look. Passing variables to the script. And I'll hold this section for a minute, mixing together make and Docker Compose. But I think you have a good idea on how to mix make with any other tool, right? If you want to run any command that you would run on your command line, your bash, you could simply put it here. For now, that's the first approach for using make. So let's move on to Docker Compose, and we'll see a different way of working with these three tools in a minute.
Then it's just one fix. This mixed together make it, and Docker is not with Docker Compose, just Docker. That's my bad on this writing.
Okay, so this should be Docker.
Yeah,
okay.
I'm sorry about that.
Now I got it, because we can just put an example, a very simple example. Let's say we want to build a Docker image. Who is building a Docker image for the project one there? Everybody, right? You could just create a make file, create a build target. Inside this build target, you're going to say Docker build some tag, and let's pass this context here for now. I'm going to save it. I'm going to create the simplest Docker file that exists. Okay, so if I run make build right now, I should have a new image. Let's see. Ta-da! Done. So developers don't need to know exactly the command you used by heart. They don't need to have big scripts or one person sending URLs and files by email or anything like that. They just need to follow a pattern in terms of building things, testing things, validating things, and deploying things. And this is the basis for our pipeline. In any repo that you execute make build, this should build things, doesn't matter what. If it's building 5 Docker images, if it's packaging, putting everything in a zip file, deleting folders, doesn't matter. Me as developer, I just come here and say make build. And this should work. But one machine is different from the other, right? That main problem that DevOps come to solve, that it worked in my machine and it's not working in yours. There's a good way to solve it. And Docker helps us in doing this, because with Docker, you put everything together on a container with all the environment, operating system, and thing. Well, not the operating system, but it will emulate using the daemon. But in a consistent way, you can rerun containers using different hosts and have the same result. So we're going to use Docker Compose to start mixing make with Docker. So first, what's Docker Compose? It's a way of running multiple containers in an organized way. So if you have a container for a database and a container for an application, and you want to run them together or using the same network because the application needs to connect to the database, and you want to use the Docker network to connect these two, running just on Docker without installing anything in your machine, probably you need to look into Docker Compose. The syntax is simple as this, but of course you can read the specification for more details. Here I'm saying I have a service called web that exposes port 5000, and I have a database, Redis, that uses this image here. This web is going to build its own image using a Docker file. Redis, no, Redis will use its own image. It's pointing to an image. So going to compose, let's just get this code. If you installed Docker on your Mac OS or Unix, probably you have these commands available, docker-compose. And you can see it has several commands similar to the Docker command. So you can run, you can say docker compose run, docker compose stop, docker compose ps to know the status of the containers. In this sense, it's very similar. You have docker compose build to build all the services. The difference is it's acting on multiple containers instead of just one when you use just docker build, docker ps, docker anything, right? Docker run. So I'll create just a simple docker compose YAML is the convention for this file name.
If anyone used Docker Compose for the exercise instead of just Docker?
No? I'm going to show something crazy.
No for now.
Related to WordPress with Docker Compose, but you won't be allowed to use it for the project one. So just going on here, I'm copying this. So I have two services, right? Web and Redis. I'm going to just copy my Docker file that I just created. I'm copying this Docker file because this service web is saying it's going to build its own image using the current context. So it will look by default for a Docker file to build it. But for Redis, for example, you don't need a Docker file because it's using an image. So it's going just to run the service using this image, right? So my folder looks like this right now. Docker compose and Docker file. If I run Docker compose build, what do you think is going to happen? Anyone?
It'll build the container.
Which one?
The one that you have the image to be copied.
This one, web
No,
server?
not the web. So the second one, Redis.
No.
Oh.
It will build the image based on the Docker file that you have in your folder.
Ah, yeah,
For
and you
which of
have
these
the Docker
services?
file. Yeah, got it.
For Redis or for web?
Web.
For web.
No, they
That's
are
correct.
gonna, yeah.
Yeah,
For
it's
me,
going
it's
to
like,
it's going to be used for web because in web we said we're going to build an image, but for Redis we're going to reuse an image. So it's going just to download from Docker Hub, for example, and reuse it. Right?
sure.
So it's going to become clearer here, you can see building web. So it's just using my simple Docker file. And it generated this image here. Compose.
So they,
yeah.
Quickly question. So they are creating one image, like the build one that they come from
yes.
doc file, but they are creating two servers, two containers.
It's not creating containers yet. It's just building, and from these two services, it's just building one of the services, which is the service web, because in the service web, I specified that I need to build it. For the second one, Redis, it's already ready to go. It's ready to run, Redis. But as you can see, I don't have any containers running at the moment. So I just built it, right? So if I say Docker image ls, we're going to see an image was built here with a SHA just, well, 2 weeks ago, because it's the first layer. I didn't modify anything. I just copied from, yeah, so it generated just one image. And Redis, I think I already have it here. So it didn't even pull it. Yep. Now for doing what you just said, Adriana, we can do Docker Compose up. It's going to bring up all the services that I have defined in the Docker Compose YAML.
Yeah.
So now the containers are running. Right? So if I just split the screen for a minute, do Docker Compose PS. Oops.
On the same folder.
Yep. Yeah, you saw that the folder is important, of course, because it will look for the Docker Compose YAML definition to run the command on. So Docker Compose PS will show that I have two containers running. One is my web container, the other one is the Redis. And they, with just one command, you brought up two containers. You can bring up any number of containers that you need. And the same way, in a similar way, you can just bring them down and stop everything, right? So it stopped both containers and removed the network it created, right? There are some other options you can use, but basically, I don't want to complicate this right now. The important thing here is understanding that you can define services in a Docker Compose YAML file. Aborted. You can define any number of services here. You can define volumes if you want to. You can define networks here. You can define a lot of entities that Docker has, and you can do via the Docker CLI. You can do it via Docker CLR, for example. Docker network ls, Docker volume ls. You can specify everything inside your Docker Compose YAML and treat it as a single unit. You'll see it's going to be useful in a minute. Let's move forward to 3Musketeers.
You guys,
before I go, any questions?
You guys probably have run the WordPress image, right? So it's a bloody long command, right? Docker run WordPress.
Yeah, my
there's
surprise, I forgot.
There's like 4 amps to type in and mount volumes. So you end up with a 3 lines command on Docker. You
Yeah.
can have all that options on a Docker Compose file, YAML file, and then just run the Docker Compose command.
I'm going to show you
Yes.
something
Beautiful.
crazy like this. So what do you think this is doing? Can somebody explain this Docker Compose file to me?
Basically, they are two services. One is like they are creating two containers in the end using two images. One from WordPress that they are those are on Docker Hub, and the first one, and you are linking. So are you missing the linking part to link both? Because the WordPress yeah, depends on. So we are saying that depends on DB, right? And DB is the first service.
Yeah, this depends on means that this service needs to run before this one, right?
Yes, but
and
could
look
I
at this.
use?
Do you know what this is doing?
Is it your port that they are using?
Yeah, but how about this DB here? What's this DB?
Connecting to the container has database.
Yeah, the DB is your service, so it's your another container.
Yeah, so what's happening here, I'm referencing inside Docker Compose file, one container from the other and using it to form my host name for the DB connection. So this is going to use the Docker internal network to solve the name, for the route to reach this DB container. So I didn't need to manage anything here in terms of DNS, IPs, or service discovery. I'm doing this service discovery here just by reusing the name of the service, DB, and passing the port 3306. And besides that, we are specifying here a volume just to hold the database data. So if I run it, sorry. You can specify another file, right? Just passing -f. Let's wait a little bit. You can see my SQL is running. You can see now that WordPress is running. Look at it.
Yeah, beautiful.
Localhost port 8000 running locally with a Docker Compose file of 15 lines of code. I put up my database, my web application, they are connected. I can just reuse it. And as it is using Docker volumes, this data will be persisted if I stop this container and run it again. So this is the orchestration benefit that Docker Compose is bringing to us. So that was just an example. Please don't use it for your project one.
But can you try to use it? Because I mean, like you link it both different the same. I did this the different way to link both containers. I've used like link something. Can I use it to like I don't know which one is like the best way to use to link content Dockers and containers.
Okay. Well, we can have a look in your implementation if you want to discuss it afterwards. Yeah, there are a bunch of commands and check the documentation. There are a lot of things that you can do with Docker Compose, but this is the minimum that we are going to see for our implementation.
Just one question. For example, if I need to documentize our API, so how is like the best way to do it? It would be because I can't wrap my head around it. Like, how will be the page or my API to be used? Because, for example, I need to give to my API some parameters. There are some arguments to be used. So how can I use parameters when I need to run some Docker file, for example, or some API which is in a Docker on a container? I mean,
right. You can use environment variables, for example.
okay.
I can, I'll show you an example. It's in the 3Musketeers content.
Oh, okay.
I'll show you an example on how to pass these values to the Docker container.
Perfect.
Which basically are environment variables, because you don't want to change too much the container behavior. Basically, you're going to change just behavior per environment. So in this sense, environment variables are usually enough. If you need to do a lot of things, maybe you should consider building a new image. It depends on your use case. I'll show you an example in a minute.
Sure.
So let's go to the next subject, 3Musketeers.
Dennis.
Yep.
I have a question. What are the best proxy for the containers? When I talk about the layers, for example, what's the best proxy? Having a container for Apache, have a container for the SO, have a container for the web layer. What's the best proxy are?
Well,
we do have it. I don't know if we have or not.
Yeah, I think, well, the way I usually use it and I see it's being used is you need to think on units, components of your solution that are independent and that may fail separately. Because what we want to achieve with containers is not only the environment isolation, right? But we want a simple way to spin up any number of containers when we need to scale up. And if a container fails as well, we want to replace it quickly. So it would make sense to have a container for, let's say, an API gateway. You have let's suppose your application is user, API gateway, backend application, and database, right?
Yeah.
So for your API gateway, you could have a set of containers because the API gateway is the one that will orchestrate and route your requests, right? If a node fails, if a container fails, you just spin up a new one. If you want to scale to 10x the volume, you just scale it, right? Then after processing this in the API gateway level, you may have several containers for the application itself. The application, the same thing. Any container may fail at any time. So you want an easy way to spin up containers. Now, you wouldn't put all the contents for API gateway in your application on a single image, because in order for spinning up quickly, you want to keep the image size to a minimum.
Okay.
So you want to be, in this case, smart to work with image sizes and putting together things that are really related and should come up together and fail together.
Can I try to give another example? So
Yeah, sure.
then is explained more into the software development or an application. But a container normally should have just one process running. So for example, you won't have the web server and the database running into the same image.
Okay.
So every time that you think, should I run this together with this other process that is running on my image, that's a good indication that you need a new image for that process. And then what Dennis is trying to explain about the application itself is, if you have one big application and the container fails, everyone on your website, for example, will drop down, will leave. But if you have a container for your authentication, a container for your listing the products on your e-commerce, and a container for your shopping carts, if the authentication is gone, it will only affect new users trying to log into your system, but maybe the ones that are already there can continue using your system. So that's the way that we normally try to think on.
Okay, cool. Thank you.
But one question, Caio, in that case, do not make hard to troubleshooting what's going on and what's going down or things like that?
But then this is a conversation about microservices or monolith applications. Some people say that prefer monolith way. Some few years ago, everything was big monolith applications. Then microservices come in, people started breaking down the application in multiple containers, and you end up with a hell of microservices that, as you said, it's quite hard to keep track and troubleshoot when something fails. Then few people are now going back to monolith application. But that's we can give a whole course about microservices and monolith applications.
Yeah.
Thank you.
Nice, guys. Thank you, Caio. So the last topic, 3Musketeers. 3Musketeers is an approach on how to develop using Docker Compose, and Make, in order to make our environments, our developer environments, and our pipelines in the end more consistent, avoiding the problem of it ran in my machine, now it's not running, this kind of stuff. It ran in my machine, when I put in the CI server, it fails. So it's basically bringing together these three tools that we already saw, right? Docker for containerizing, Docker Compose for bringing multiple containers together, and Make to organize the steps in a way that, like in this pipeline here, Linux user, Mac OS, Windows user, your CI/CD server, they can just run make build, for example, and it will use Docker Compose services to spin up containers, Docker containers, do the job that you are looking for, like compiling, like compiling your application, packaging your application, deploying to AWS. It will do the job inside the container and output the artifact if needed. But the process is always consistent. If you have 10 repos will have, for example, make build, make test, make run. So it's easy for new developers to understand how things work, because despite the scripts that are changing on per repo, right? Per repo, you do a different build probably. But the way you approach the repo is knowing that if you run make build, you'll build the thing. It doesn't matter what's happening, right, in your scripts. So it's a way of standardizing and improving developer experience. And as everything runs in Docker, the build, tests, the packaging, you achieve consistency as well. So you have these three main benefits. Consistency, because any user, even using Windows, they could compile, I don't know, I have an R application, but I don't have R installed in my machine. Well, during the 3Musketeers approach, I would just need to run make build, for example. It would spin up a container with all the tools needed to compile it and give me the output. I don't need to install R, Ruby, Python, .NET, Java in my machine. We're going just to leverage the containers for doing that for us, right? We'll have control over the versions in our pipelines, and our pipelines will be so much simpler, as you'll see. And confidence, basically, because what will run in your machine is running almost in a hole inside the container. And when you do it in the CI server, it's also going to run in the container. So there's not many reasons for it to fail. It might fail, and you're going to see why. Like the question that Adriana asked about injecting environment variables or injecting variables in these Docker Compose definitions. So if you're injecting something, you probably end up changing the way it's behaving. So that's when it might fail, right? That's when it might fail. If I run with the same argument here, if I pass always the same variables to the container, it should run the same way here in my machine, on a Windows machine, or in machine running Docker. If I manipulate the parameters and I keep changing them, the way they are manipulated inside this Docker container might make the Docker container fail, the process fail. But let's go step by step. Let's
so
bring this.
So the idea is always create something static.
The idea is shifting left anything related to infra in a way that we can reproduce in our machines, right? Mainly about CI pipelines, because everybody will need to code something, version it somewhere, then building it, like compiling and downloading dependencies, then packaging it, putting everything together for a release, then deploying it. These are the basic steps of any software lifecycle, right? I'm not talking about DevOps, but any software lifecycle, even in waterfall. Waterfall, we do this. The idea is shifting left in a way we can automate it. And with a single command, you can run all of these 6 steps that I just mentioned in your machine, and it will run the same way in the CI pipeline. And you're going to see there's no magic in this. Sorry?
Oh, yeah, but my question was about, like, for example, if I just, as we are creating different containers, one day maybe I will just change, instead of MySQL, I would use Hadoop, for example. And I want to change the database.
Okay.
Of one container or of one.
Yeah, you could. You could easily, if it's containerized, you could change your image to a different database. Then you need to adapt your application probably, right? And you could run it locally. Yeah, you could easily change it.
I think she's saying something more like, then every time that I start my container, I pass as an environmental variable the database string. So this will be one thing that can be changed every time that you run an image. That's one thing that you can do, yeah. Then it's saying exactly that you can do that. It's just that it's best practice to don't change as much as possible the final behavior of your image, because the idea is to have an image that will be always the same every time that you run it.
Yeah, keep the external dependencies to a minimum so we can grant more consistency in your flow. At this company I'm working on right now, we have a lot of environment variables, and we inject them in these Docker Compose files that will get injected to the containers. And yeah, if you change anything in this environment variables, it will break probably. So these are variables regarding proxy configurations, for example. So depending on the proxy configuration, you cannot even download the dependencies of your configuration, right? So yeah, keep it to a minimum. I think that's the main takeaway. And I'm going to show how to inject it in a minute. Just to bring these tools together, there's an example of a hello world here. Let's suppose we're doing a make echo. So same thing that we've done, an echo target. These echo targets in the make file have a Docker Compose run Alpine. Alpine is the name of the service, right? And it's passing a command here. We'll get to it in a minute. The Docker Compose file defines the Alpine service that uses the image Alpine, right? Here you can see it's leveraging the commands that you can pass to Docker container. So this echo hello world is nothing more than a command that you're asking for this image to run, right? So putting this together, when you run make echo, you're going to trigger this target that will call this, will run this container for the service Alpine, that will run this container Alpine, right? And it's going to run this echo hello world inside the container. It could be anything. It could be a .NET image here, a Java image. I mean Java image as in an image with all the Java dependencies installed, right? You don't have Java in your local machine. Then you use this, this target here to run the Java service and ask it to compile all of our .java files and output just a jar, for example. So you can shift this all to the container. This is the main takeaway from these 3Musketeers. Then there are some patterns, and there's a very good documentation. It's good because it's simple and short. In this 3musketeers.io, you can see some patterns and how it works basically. So you have get started, then make Docker and compose a session about environment variables if you want to inject information in the container. And it has plenty of examples for you to follow. So I really recommend reading this. I just highlighted here 4 patterns. So let's check, let's go one by one quickly. The first one is about separating shell and language files from the make file. So in our example here, we didn't have a make file. Okay. I'll use these examples from this link here. Do you remember when I did the hello target here for this one? You see that I have 2 lines of code here. This can become big. So you can just extract this as a separate script and ask it to execute, let's say, hello word.sh. Then we remove it from here and just keep it very simple, saying basically, this hello target will call a new terminal, a new session, and call this hello world.sh. This file. I'll change it a little bit. Let's see if it works. If I need to change the, okay. Yeah. So I just executed the contents of the hello world.sh file, which is a bash script file from my target. So that's a good way of organizing your code. It could be anything. If you want to run a Node or a Python script here, you could just call the container first, right? So that's the first pattern, separating the shell, the make files from shell and language specific files. Next one, if you're talking about any specific technology specific target, if you're going to call something that's related to Node.js, Python, .NET, Java, we usually put an underscore in the beginning of the target. So in this case, I'm using this bash script, right? I could have a target here called underscore hello. Let me do something more. I'd like to, I'll run here. I'll run here the Docker container from my target, passing the script as the contents that I need to execute inside of it.
It's Docker Compose, Dennis.
Yeah, I don't have it in my composer file. That's why I didn't put Docker Compose. Okay. Let's see how it goes. Hello world.sh. So what we have here, hello target, calling a Docker container, and soon we'll see it's a Docker Compose service, in fact, which will use Alpine, and I hope Alpine has make installed in it, because this command here will run inside Alpine. And it will look for this target underscore hello. I think this example is becoming more complex than and it should be. Let's see. Work dir can be W here, Kyle, you know?
No.
No? Okay. I have better examples here, guys. So I don't want to make it complex and nobody will understand it and it might fail yet. So I'll follow the patterns here that will be easier, because the idea is the same. I'm just rewriting this again. We want to have a reference to a Docker Compose or a Docker command that contains our service. And when we run a make target, we want to run it inside a Docker container, right? Just refer to this pipeline here. We are running a make target. We want it to run inside the Docker container. and we are using Docker Compose to achieve it. So a way of organizing this is creating variables for Docker Compose services. So for every service that you have in your Docker Compose, you have a different variable in your make file. And when you want to execute a target, in the target definition, you just pass the command and complete it with the inner make target that you want to run inside of it. So this could be just the echo hello world that we just did. But one step further, putting this second part pattern into place, we're leaving all the technology specific targets in the beginning with underscore. So make deploy here could be AWS CloudFormation deploy. It's going to be a technology specific command, you know? It's not related to Docker, it's not related to make. It's going to be .NET something or a Java package manager, right? So you're going to leave these specific things in the underscore targets. In the main targets, we're just going to call the Docker Compose service and pass the command as a parameter. And to finish up the patterns, the main patterns, we would need to offer to developers cleanup targets. So I built all of these containers. So I downloaded a lot of images, but I'd like to clean it up. I'd like to remove all the volumes of the images that I downloaded. I don't need it. I was just playing. So usually we create targets to clean up temporary directories that were created and Docker images, volumes, networks, anything that was created in this flow. So putting all of this together, I think this is the example that I'd like to show. I'm closing this one. So what we have here, I'll begin from the bottom. Our Docker Compose YAML file, we are declaring a Python service. This Python service is going to use the Python image from GitHub. And it just sets the working directory and the volumes to map from my local to the container, right? So basically I'll have this view of my code, my local directory inside of the container in this working directory. So that's the Docker Compose one. When I want to test it, in this case, I want to test it only, I'm going to just declare my Docker Compose service as a variable in the beginning. And in my test target, I'm using that Docker Compose service, calling my make underscore test command. This is going to run inside of the container. So I need to be sure that this container has the make application, right? Because not all the containers will have it installed by default. So this make target will run inside the container looking for underscore test. And finally, my underscore test target will call bash scripts / underscore test.sh. And this file is simply a script file. This could be our hello world here. So you can see all the 4 patterns applied here. Separate shell language files. We do have it. We have a separate file underscore test.sh with a new make target. Technology specific targets with underscore. Yep, just mentioned that. Docker Compose commands as variables. We have it here, declared in our make file. And the last one I didn't include. It's the clean one to clean up this this Docker container. It will be exactly this: Docker compose down and remove orphans. This will remove my my containers, networks, and volumes. That's it. There's a session about environment variables here. This is the last thing of this part of the class. Do you have any questions up to this point?
Yeah. Are you using validate and test for what? I think I missed.
The flow here is exactly the same flow depicted here. So you, as a user, you're going to clone this repo, for example, and you're going to run make test. When you do it, it's this target here is going to be called. This target will run a Docker Compose service called Python.
Dennis, I think the problem is with the validate target on the side of the test. So
I just abstracted. I'll remove it.
That's all right. And then you do a make test. So can I, because for example, make it underscore test would be another variable, and as you explained, we can put a variable, one variable and two variables like follow each other. So why are you not using like test and then underscore test to run?
It's just a pattern. It's because of the pattern. In fact, you could have these exactly here in front of the Docker Compose command. You don't really need this underscore test one.
Yeah, sure. But my question is, for example, could I put underscore test after test without underscore to do the pipeline to be run?
Oh, yeah, you're saying, could you do this?
Test and so underscore test.
I think she's saying to add as a target the underscore test after test. So if you run make test, runs the underscore test, you can, but then if you just run the underscore test by itself, then you need to have bash on your local. Then you're not running through the container.
All right, I got it. So this one open, like it's working into the within a container.
Exactly. From this point on, from this command on, everything inside this underscore test is going to be executed inside the container, including this make command.
Okay.
Because
so I can, for example, could instead of underscore test, I could have another make file telling them what I want to then do. A lot of, or like a huge command to be run.
Yeah, you could have well, anything, right? Here I'm using bash scripts, but you can have big scripts in any language running here. So in your case, I think you work with R, right?
I work with Python and R and whatever.
Yeah, so Python, we don't really need to compile it.
Yeah.
But if you want to run pip install, for example, and you don't have Python installed in your machine, you'd follow an approach very similar to this one. You declare a new image for Python, you have a target here, and inside this script here, you have your pip install as I have here.
Yeah, sure. This part I got it. I was confused with making underscore
Is it
text.
clear now?
Yeah, sure.
It's just a way of organizing the code. It's not really doing anything special, but when it grows, the makefile grows, it helps us to understand it. It's clearer, right?
Thank you.
I've got a question.
Yep.
Maybe a bit silly, but from my understanding, the 3Musketeers approach seems very useful for developers. So for example, if you're working with other developers, you create a container with your code in there and then you share it amongst each other. But how does this fit in with like the other piece of DevOps coming from the infrastructure point of view? Like, are you able to use this type of approach to deploy into AWS or Azure or into another tech stack like that? How do the parts merge together? Or is this only a kind of like a developer tool?
It's more of a developer experience and consistency approach. But let me give you an example. If I have a target called deploy, so I can do make deploy. Let's suppose before I was using Terraform for deploying it. So I had a deploy here, underscore deploy here. I script with Terraform plan, Terraform apply, and it was just working fine. I didn't have a Terraform installed in my machine, but as it's running inside the container had the Terraform CLI installed, so everything was working perfectly. Let's suppose we decide to move out Terraform and use CloudFormation, which is another infra as code tool from AWS. I still want to do make deploy. I don't want to care much about the way it's running. Make deploy should deploy. This is me as developer in a team, not worrying about specific details when I don't need it. So somebody else just migrated from Terraform and now they're using CloudFormation. And for deploying CloudFormation, you don't use Terraform CLI anymore. You're going to need the AWS CLI. So this person can just come here, declare a new service in your Docker Compose, and this service will point to an image that has AWS CLI, because I don't have it locally either. Then this person will declare in makefile compose run AWS, pointing to this AWS service, and they will change only the contents of my underscore deploy.sh. So the developer experience is exactly the same. I just need to run make deploy, but right now it's going to spin up a new container with AWS CLI. It's going to run a new script that I'm not aware of, but I don't care much. And it's going to deploy the same way. So as a developer, it abstracted all the complexity for me. That's when things relate, I think.
Also, Matt, considering the WordPress project that you guys are working on, there is nothing related to development in this project. I mean, you guys are not developing any code there in terms of web services, Python, PHP, nothing. And everything can be done through those 3Musketeers approach. Building the image, deploying to AWS, making tests to the image locally. So it's not something only for developers. It's very beneficial for developers, but this is used through the entire CI/CD process. So in the integration side, which is more of a developer, but also in the deployment, which is more of a operations and infrastructure team.
Cool. Gotcha.
Yeah. Oh yeah.
Even if it GitHub, for example, we can easily I can see like you can use the make for GitHub. Am I wrong? Am I right? Like, for example, the GitHub, and you like do everything that I need to run to do my comment and everything?
Potentially. You can automate anything, right?
Yes, exactly.
Now, yeah, you need to balance if it's going to be good on the long running, but if it's worth automating, this is an approach that you can use for automate anything. It's not only for developers in the sense. And Kyle will show how it make the pipeline silly, because as I mentioned in this example, make deploy, the pipeline wouldn't really change because the pipeline will still call make deploy. So you don't need to change. There's a place you're going to see it in Kyle's class. There's a place you're going to define your steps, and you want to keep it this simple, very simple. So you don't want to refactor this CI pipeline every time a thing changes. About environment variables, I'm just going to mention one thing. In the Docker Compose file, you can pass env_file attribute with the name of a file. Usually it's called .env. And this file .env, it has variable names and values. If you put a equals something here, it's going to set the value. And these environment variables are going to be available for your container. So any logic that you want to run based on environment, for example, different connection strings for different environments, that's a very common one. You can pass it as an environment variable. Or you can just state in this .env file the name of the environment variable without a value, and it's going to use the value from the host running the Docker command. You're going to do some exercises, it's going to be clearer. But if I'm running locally, I'm pointing to my local host 3306. In my CI server, I have a DB connection environment variable as well, but the value is CI domain port 3306. So it's a different value, but the name of the environment variable is the same. So the only thing that you are interested in is getting this environment variable inside the container, even if it's fetching this value from the host machine. And you may have several .env files, .env-dev, .env-prod, and there's a pattern in 3Musketeers for handling these environment variables as well, these .env files. Please have a read in this environment variable section here. It's not complex, but he presents here several patterns. And basically, we just need to reuse this file in your Docker container. So this env_file is the main takeaway for these environment variables, right? You're going to do some exercises. It's going to become clearer how it affects the container. For example, how do you inject the AWS keys inside a container? You can set them in your local environment variables, right? We saw this. AWS access key ID, AWS secret access key. If you create a .env file with these two environment variable names here and pass it as this to the container, you're going to have these values there for you to use. So you don't need to do anything else. This is going to be one of the exercises you're going to do. Fetch credentials locally and see it running using 3Musketeers inside a container. And there's a full example here with some references pointing to this, the original repo from this guy. So this is a real application. In fact, this is the application that created this site here. He just followed the 3Musketeers approach to create a website about 3Musketeers.
You went missing. Cool. I'm going to start because this is not part of my class. I just want to show you something to answer the Matt question. So Matt said that 3Musketeers is good only for software development, but it's not. Like it's the thing that we most use on our days, like because it's abstract, the whole thing. So you don't need to know what the process or what the pipeline steps are doing. You just need to, as Dennis said, type, make build, make deploy, and something is going to happen. So I'm going to show you a quick example here. This is our repository, so Academy repository. If you guys have browsed around, you see that there is a script here that we have some automation going on, and the whole thing on GitHub is actually being done through Terraform. So all your username invites, the repository, the things, the groups, all the repository, it's all Terraform. So we don't do any manual steps on github.com. And this is you guys can see my console, right? And a Visual Studio Code. So as you can see, I don't have Terraform installed on my computer. So a pipeline.
Just zoom out a bit.
So a pipeline, a common pipeline for Terraform would be something like that. So I don't have Terraform again, don't have. So I'm going to run it through using Makefile. My Makefile has an apply, plan, and a init. My plan and all the targets run Docker Compose. So 3Musketeers. Plan, apply, init. To run this GitHub automation, the only variable that I need it's a GitHub token that I will have to create another one after the class because I just exposed it. So as Dan said, I'm declaring a variable, and every time that I run my Docker Compose, I can use that variable. Quite simple. Again, I don't want to, every time that I run my Docker Compose file here, print my credentials on the console. So I'm using this guy here, this target called silent. So whatever is below silent, it's not gonna print. It's exactly the same as the @ before each command. So if instead of running Terraform init, Terraform plan, Terraform apply, all of that, I can just do like a make plan. That's gonna use Terraform image. So that's my Docker Compose. I just using Terraform, and it's mounting my local files to work folder. And I'm putting on my plan here and saying to print my plan to a file. So I didn't have any file. I don't have the file here on the script. So, and I don't have Terraform on my PC. So it's definitely been doing through the image itself. So you guys can see my plan is to add 2 things. And now I have a file here that was generated through the image. So that way I can reuse that file on my apply. You know, when you do make plan and you do a make apply, you actually need to type yes again, just to confirm that you want that. So now I'm saying that my Terraform apply should use a Terraform plan file, and then I don't need to accept it. If I run make apply, we'll just run that. Just want to show a real example of an automation for infrastructure. Actually, it's not software development. Cool. Let's move to the class. So far, sorry, starting again. I don't know if you guys have noticed that the type of approach that we've been trying to do. Like we started with everything manually. we were doing a bunch of console clicks, and it was a very manual process to get to do that. Then we showed you guys a few tools that you could use, like AWS CLI, now Terraform, and Makefile now, and Bash scripts. But it's still it's a very manual process, right? You still have to type Terraform plan, Terraform apply, or run make commands, and it's not real automated, right? It's easier, but it's not automated. So that's the main idea of having a pipeline. So what is a pipeline? A pipeline is just some set of tools, or sorry, it's a set of automated tasks that it's going to run. And normally it's commonly associated with software. Wait, my Siri here is getting crazy talking to me. Stop. Let's continue. So I don't know what's happening. Hold on. Issues. Cool. Sorry about that. Some technical issues. So a pipeline is a series of automated tasks. So like it could be scripts that can get code changes deployed to where those codes are running. A pipeline is not just for software development, for applications. It could just be an automation. For example, we use pipelines to tag each one of your pull requests with a ready to review tag. So that's not a software development or application type of pipeline. It's just an automation. So we created a set of tasks that every time someone creates a pull request, it gets tagged with ready to review. So it makes our job easier to know if there is any PR to be reviewed. A pipeline for software development process helps you to make sure that all the code coming through and getting developed by one or multiple developers is safe to get deployed to your environment. So during that pipeline, your tasks, you could have many features that will make sure that your code is ready to be deployed. So for example, if your code is not building, you missed something on your code and it's not even building. If you deploy that code to production, it's going to break your system. But if your code goes through a pipeline, a series of automated tasks, and check if your code is at least building, it's not going to break. So that's what a pipeline is. And then one example of pipeline here, I have a simple picture here with a few common steps of a pipeline that are tests. So your code, going back a little bit. So normally, like you have to trigger your pipeline. You have to start it somehow. It could be a manual process, like something that you need to go and say, start my automation. And then the automation goes, get your latest code and do all your, whatever you want to do with the code. But in our world, normally we have automated pipelines, triggered pipelines that normally are triggered by, for example, pushing code to a specific branch on GitHub. So you can create those pipelines that will keep checking if there is any new code on a master branch, for example. It gets triggered and then goes through the whole pipeline, all the steps of the pipeline. And then, as I said, as an example, you could do some testing, build, deploy to some environments until it gets to production. So going through a little bit more deep dive into those steps. So and just to be clear, like every step of the pipeline is just scripts. You're just running scripts and scripts for that. We are just giving names to the steps. So for example, a test stage could be something like checking the syntax on your code. The syntax will be, for example, checking if there is any indentation issues. There are a few languages that needs to be properly indented, like Python. So you have issues if you don't have a proper indentation. It's not just for layout and to make things look nice. We normally call, or if it's missing a comma or something like that, if it's not even, if there is syntax issues. Or it could be linting. Linting is just formatting the code. So you could, before your code getting pushed to the branch, you could agree and have patterns between your developers to have that way of writing code. So you could run a linting on that. And unit tests when you're testing individual functions and individual pieces of your code. It's important to note that a few unit tests requires the application to be fully built and running to be able to run specific parts. So you have to plan your pipeline around that. If you're, for example, if Python, it's a good example, you don't need to compile, as Dennis mentioned before. You probably can run unit tests on the test phase, but you might need to run the tests for linting and syntax issues, and then build your application, then run tests again, some other types of tests. And then you can have another step and call it a build, whereas you need to download the required package for your application. Let's say we are not talking about containers. It's you're deploying a Python application, and then you need to run you need to install the libraries to be able to run your application. So you're going to run, for example, a pip install. I'm sure you guys have run to install the AWS CLI before. You could then actually run the commands to build your application, and then maybe tag it. A good strategy, a common strategy used for versioning your application is tagging it either with numbers, for example, 1.0, 2.0, or 1.0.1 for minor versions, and some other way of versioning your applications. And it's more used when using with containers. It's using the commit SHA. You remember what is a commit SHA, right? So if you get a commit here, for each commit, we have this number that identifies the commit, and it's called SHA. So you're not going to tag your image with this whole number here. It's going to be messy to remember what image is. But then a short SHA, it's normally the last 4 or 6 or whatever, 8 maybe, the last 8 numbers of your commit. So you as soon as you download the required package and you build your image, and you tag it with the last digits of your SHA, commit SHA. So you know that for that image, that is the commit number that I use. That was the point in time of my code for that image. You guys understand that? Cool. It's a good practice before leaving the build phase to actually remove any package that was required just to compile your image. A few applications, you generate a binary file, or you generate your image file, and then you might not need some package that you use it maybe for running tests or to compile the applications as well. And then it's a good practice to remove those to make your final artifact. We use that word. Artifact is the final product of your application in a final stage that is going to be deployed to your environment. It's a good practice to clean up and have it as small as possible. That's when dealing with container image, you also will change your base image to Alpine or something like that, which won't have any package running inside the image. And then you have your deployment, your first deployment, which will be something like a deploying to a development stage, a test stage, just to make sure your application runs and you can do some tests. And then from here, you can actually run maybe some other tests, some more complex tests that you need integration with other systems. Then your application needs to be running to be able to communicate with other systems, and you can run tests based on that. You can have some other sets of tests. That's why on my image here, between deploying to development and between deployment to production, there is a 3 dots, because you can have any number of steps here. It depends on your environment. For example, if it's a regulated environment, a bank, for example, you might want to run some security checks to see if your application doesn't have any vulnerabilities on the code, something like that. And then in the end, you can then deploy to production and make your code available to your users. What do you mean by deploying to production? In old days, it could be like, as I mentioned here, stopping at the web server, deleting the files that are running there, getting the new files across, and then starting the web server again. Or the container way of doing would be pretty much stopping the image that is running and creating a new one. That will be a production. But that we are just talking about automating the tasks that we've been doing during this all these weeks. There's nothing about CI/CD or anything. It's pretty much, instead of typing every time in the commands, just having something that as soon as you hit a button or it gets triggered because there is a push of new code to a branch, is just start doing all the scripts for you. So for example, if I was doing my Terraform that I showed you before, would be something, if I post a new thing to create a new repository on GitHub, as soon as it gets merged to master, my pipeline will run Terraform plan. If no issues, we'll run Terraform apply on that code. And that's it. I don't need to go and type by myself Terraform plan and apply. Or even worse, if every time that I need to do Terraform plan and apply for the GitHub, I need to set up my GitHub token. And it's a pain to have to keep having to set up this. Whereas if I have my automated pipeline, it will have that value as a secret already. And then this is all theory. There won't be much practice around this. So we have this, after we understand what a pipeline is, then it comes, what is continuous integration and what is continuous deployment? Those are just patterns, and it's just a theory of why we do things on this way. It doesn't mean that you have to do this way or not. It's just that it makes your job easier if you follow those patterns, and then whoever comes after you will be easier to go from that and just keep doing the work because you're following the best practice. So the continuous integration part, it's the most easible part to achieve, because it goes up until the deployment to a development environment, somewhere like that. Some people could say that the continuous integration even go into the development parts, because you still have tests to do here. And then the continuous deployment is the second part. So let's just deep dive a little bit on continuous integration. So why this continuous integration thing? It's just that it's something that keeps incentivizing the developers to keep pushing code. Like before that, a few years back, developers would just like keep developing for a week worth of code, and then you have this whole big change, like as I said, a week worth of code, and then I want to merge all that stuff to Git, and then once I create my PR, it's 1,500 files changed, and then 500 of those are failing for some reasons, and I'm not able to make my code work anymore. So I'd rather just keep pushing. Like every time that I create a new, when I do a small change on my code, git commit, git push. As soon as I do a git push, this continuous integration part of my pipeline will run my syntax tests, will do my linting, will try to build my application with that new change that I just, like a small change. and will return back to me a status saying, okay, your application is still building and you can test it now, because like you can run it on your development environment and see your new change. So that's the idea of continuous integration. Like it's making sure your code is, you get feedback fast for the work that you are doing. Pipeline stages are normally dependent from the past one. So what I mean is, if I run the first step of is syntax checks. If the syntax check fails, I'm not gonna even run the build part, because I know it's not gonna build if I have a missing comma or a wrong spacing, a wrong tab. Sometimes you understand what the issue is. For example, you might be getting a package that is from, you're trying to download a package that is from a source that is not available in the moment, and you know that that's not going to interfere on your code. So administrators normally can go and overwrite the step and say, no, just keep going. But it's not recommended, of course, and that could lead to it's quite often we get like you get a new repository to work on, and then you start doing some small change that you know that you're not affecting the whole application. And then once you push your code, your pipeline fails, and you said like, no, I haven't done anything, nothing major, and not even related with this thing that is failing now. Then you see that, and then you see that some other developer push his code, break the application, and it was like, okay, I'll just make it go ahead because it's not my problem right now with that. And then you have to fix that other issue first before it coming back to your work. So that's the continuous integration part. So test, building, and up until the deploying to the first environments. Not then from that it comes the continuous deployment part. The continuous deployment it's like an utopia. Like it's your best scenario, best case that you can have. For example, it's an end-to-end automation. You push your code to a master branch. Let's say if your code gets to a master branch, it's going to go through the whole pipeline. If nothing fails, it's going to get deployed to production, and your users will access it straight away. That's really, really hard to achieve. Like it's only a few companies, very mature companies, that have all the automation in place, all the security checks, all the testing and everything. Imagine Amazon e-commerce. Would they do a full deployment to production every time that someone pushes new code? Do you think they would do that? They actually do, like probably more than 1,000 times per day, because they are comfortable that all their tests are in place. And if the code has issues, the test will pick up the issue and the test won't go to production. So that's how complex you can get. So there is quite a few items that you need to consider when you are building the last part of your pipeline, which is deploying in an automatic way to the production. And it could be, as I said, maturity of your automated testing. So if all your tests are in place, you could use tools to check for vulnerabilities on your code. That could help as well. And on high regulated environments, sometimes it's not possible. Like you can't run a new version of your application before someone with some authorization signs up, like, look, I authorize this new application to run. Normally on banks and companies that deals with betting, they have this. You can't, like, someone needs to actually sign a paper releasing the new version to be able to go to production. So the pipelines can get steps that needs a manual interaction with it. So it can go through the whole pipeline, all the testings, builds, and more testing and everything else. And then once it gets to the last point, it says like your application is ready to go to production. I just need someone to hit a button, and then maybe sends an email or a Slack message to this person that have authorization to go forward. And then the person maybe just need to go into a console, a UI, and hit the button to deploy to production, because he will be confident that the code is ready to be deployed. He just needed to authorize. Or even you can build automations for Slack that the message that the person receives has a button that you just click the button and gets deployed. For production, this is done like CI/CD. That's what CI/CD is, pretty much. I added a little bit of information on different types of deployment that we could use. This is just some complement to the content. So the most common one is in place deployment, which is pretty much whatever version of the application is running, you just deploy a new one. That's the simplest one. Of course, it's cheap because you just have one single environment. You don't have any extra costs for that. But of course, it's the one that probably have more extended time of downtime, because you need to stop whatever is running and start running a new one. And if you find out that there was some bugs that you missed it, or your pipeline didn't pick up, you again will have to stop the application and deploy the new one. So it's the simplest one, but it has some down. Another one is the blue-green one. So blue-green means that you have your environment, for example, here. So you have your environment called blue, your application blue, and let's say it's the version 1.0 of your application running. Your end users go to app.academy.com, and your DNS will point that to blue.app.academy.com, and your users will just keep using that. It's the current version, is running, and it's all good. And then you come up with version 2.0. The code goes through the whole pipeline, gets deployed to a whole new environment. So it's an environment that people don't know about it. It's called green.app.academy.com. Of course, you can go, instead of going to app.academy, maybe you could go to green.app.academy.com and test your application, make sure, okay, it's all good, ready to start getting users. So you go in your DNS and you switch you update the app.academy.com records from blue to green, and then every new user that comes in will be using now, will be going through now to the green application. Of course, it's expensive because you need to have two environments running at the same time, so there's more costs involved. But it's a matter of just updating your DNS records, and you will get back to the version that was just deployed before. So you deploy the new version, you switch your users, you find out there was a bug, you just switch it back to the blue one that you know that is working. So it's a very low downtime, or if no downtime. It's always a good practice when doing blue-greens to have the DNS TTL, the time to leave, the time that record takes to update its value to as minimum as possible, so it gets changed and propagated very quick. And another one is called Canary, which essentially is sending a percentage of your users to one of your environments and another percentage to another to the other environment. So that way you can, instead of just switching all your users to your new application, your new code, you change it, like, let's say, I will say just 25% of my users to my new code until I'm happy that it's working. Because imagine if it's an e-commerce and has a bug on a payment issue, I'd rather just find out with a few users than just with all my users at the same time. I can't do this just with plain DNS, so I need to use some more complex tools. For example, the Amazon application load balancer, I can do some advanced routing and send a few percentage of my users to a different path when they hit the main DNS application. You guys have any questions until here?
I do, just a quick one. So now the trending is like publishing the live environment like daily or weekly. Is something really short. It's not like as was before, just once a week or once a month. So the trending now is deploying to the live environment.
That gets together with the agile methodology, right? So we split the tasks in small components, and as soon as we have that component finished and ready to be deployed, there's no point of not deploying that. It's companies these days prefer to keep doing small changes on the code, even multiple times per day, than waiting a month or 3 months to go to do one big release, because you guys know that it doesn't matter whatever how many tests we do, you end users always find something wrong on our code. So that's something that happens quite often. So I rather just keep doing small changes on my code and getting that deployed and to my end users and get that tested by then, than doing a big release and that can insert so many issues to my code in one go.
Sorry,
that's the trend, yeah.
Anyone can think in another reason to do that? I mean, do multiple deployments a day or a week instead of a big deployment every month or every 15 days?
Would be because it would be easier to identify the problem or to have the rollback or something like that.
That's another reason. Anyone else with another reason?
To see how your progress is going.
Yep. Yeah, I think that the other way to say that, Adrian, is to deliver value to the customer, right? Because what is the point of developing something that you will spend 3 months to deliver to the customer? Probably another company is already delivering this during these 3 months. So as much of as faster as you can deliver new features for your customer, the better it is, because the customer are using your software and getting value from these new features much faster than in the previous way of deploying things. So yeah, those are the main reasons behind it.
Yeah, it goes back to the method to the agile methodology that we learned on the first week. So how do we create our pipeline to, like, now we need to connect all the dots that we've seen on the DevOps Academy since day 2 or 3 that we actually start doing practical things, like how can we connect all of that. So as I said before, a pipeline is just a series of scripts. It could be a Chrome script on your Unix machine that every 5 minutes runs a bash that will go and check github.com, like as github.com, GitLab, Bitbucket, all modern source control tools have all the information that we can see here, like this README file on APIs. So you can access that information through API calls. So if you make an API call to github.com and say, is there any change on the master branch? What is the latest commit for the master branch? Then the API will return me what is the SHA number. And then I can compare if there was any new change on that, for example. So I could run a cron job on my Unix system that every 5 minutes just go and check the master branch of my repository and see if there is any new change. If there is a change, I just check out that code, stop my web server, delete all the files from the static folder, deploy the new ones, and start my server. Done. Pipeline. You don't need anything fancy to have a pipeline. But of course, it's not recommended. There is so many tools in the market these days to create your pipelines. And that is a new word that you guys are getting into it, because there is so many tools to do CI/CD pipelines around the market. Many of them are paid tools. There is quite a few that are open source. Some that offer both. They are for free for the community. There is some limitations. Maybe you can run, for example, GitHub Actions. You can run 2,000 minutes per month, which is pretty reasonable for free. But they offer enterprise services as well if you want to pay and have more features. So a few, the most known tools, not the most known, a few tools from the market. Jenkins is one of the oldest one around. It's open source. They do offer an enterprise product that you need to pay for it. I never used it before. I think it's called Jenkins X. Jenkins is quite powerful. It's just that you need to maintain the server and everything. So you need to maintain the instance where Jenkins is running, then install Jenkins on it and maintain the whole thing, and then create your pipelines and stuff. For being quite complex and having quite a few features, it kind of became a very complex tool to operate. So it requires quite a bit of effort to have it running. I highly recommend it. It's pretty good, but there is quite a deep learning curve for Jenkins. And you can do anything that the best paid tool in the market can do with Jenkins. It's just that it will require you to go and manually set up and do the maintenance of that. GitHub Actions, it's the one that will be doing some exercise on it, and for your projects as well, we expect you guys to run on GitHub Actions. It is, as I said, there is a free tier, let's say like that you can run runner. So when you have managed services for CI/CD, for example, GitHub Actions, it's a managed service. Like AWS has a few services that you don't need to install. For example, the load balancer, you don't need to install load balancer, you just consume that service. So GitHub Actions, it's a managed service. You don't need to maintain the servers behind. You just need to create your pipeline and use it. But those CI/CD tools that are managed, they have this concept called runners. Runners are the machine that will actually execute your code. And those runners can be either shared ones, public ones, that most of the tools offer for free. As I said, GitHub offers 2,000 minutes on free on shared runners, or you can have your own runners. What I mean by own runners, I can launch an EC2 instance, install the GitHub Actions service on it, and then we'll have to enter what is the GitHub token and secret to link that EC2 instance to my GitHub account. And then my runner will be available to be used by my GitHub account. So every time that I want a pipeline to run a script and automation, it will start my runner and will send a job to my runner, and my runner will execute those commands. Anyone can tell me why I would use a shared runner, like something that is public and anyone can use, or I would use my private runner running on my own EC2 instance? Any guess?
So if you have sensitive information, you could use your own runners. And if you have something that is public, and you can use just the shared ones. And maybe with the dedicated ones, you can run more tasks in less time. I don't know if
it's pretty much that
way.
Yeah, just I'm pretty sure GitHub will try as much as possible to, if I run a command, a code on a shared runner, I won't be able to see what Danny's runners are doing, even if we are using the same runner, but we probably are using independent process that we won't be able to see each other files and stuff. But they are not going to guarantee that that's not going to happen. Like they won't take any responsibility if this happen if I find a way of checking what Danny's files are, what are his pipelines and stuff. So if I'm using a shared one, I wouldn't put my, for example, an application that is it's private for my company or something like that. Or if I'm dealing with customer data or something like that. With secrets and passwords we call secrets, this type of information. You could use shared ones. Just take care with it. Like if it depends on what company you are doing the work for. For example, to do the tagging of our pull requests, we use a shared one, and we have something sensitive there. We do use the GitHub token to be able to interact with the API. But we know that it's not something that if that gets accessed by someone from external people, it's not going to cause much harm on it, because we are not hard coding the token on the command itself, and the token itself is being saved in like a database, and it's encrypted. So, and only our GitHub accounts have access to it. So it's still a little bit safe. Of course, if you are working for a regulated company, a bank, you won't be able to do that. And then you have to use your private runners. GitLab pipelines, just continuing on the tools. GitLab pipelines, it's pretty much the same as GitHub Actions. They do offer shared public runners, and you can also add your own private ones. Circle CI, it's a fully managed solution that you can add private runners to it as well. They do have some trial, some free tier. I think you can run up to 100 pipelines per month or something like that. I'm not 100% sure. Build Kite, my own preference. I think Kiko and Dennis also agree with that. It's one of the best tools around. It is super complete. Like there is everything that you need to create a pipeline, but it can get quite expensive. So even big enterprise companies gave up on using their solution because it can get quite expensive. And AWS also offers a pipeline feature that it's called AWS Code Pipeline. We decided to stick with GitHub Actions to make your life a little bit easier. So we're not introducing any more features at this point in time for this. So you already know GitHub. It's just one more thing to use there. When you go to AWS Code Pipeline, you normally need to use some other tools like Code Commit, which is their source control, and Code Build, with it's kind of their runners for the pipeline. But I would say just go and do a bit of check on that documentation as well. And that is it for CI/CD for CI/CD. I'm gonna cover quite fast about GitHub Actions, and it will be wrapping up for tonight. So GitHub Actions. It's the one that we are expecting you guys to use for the projects. We are not giving you guys a lot of exercise for this week. So we know that you have the project to finish by next class. So it's just 2 basics. I think there is 1 or 2 exercise for 3Musketeers and 1 or 2 exercise for GitHub Actions, because you guys need to anyway, you need to learn GitHub Actions for the project. So might be just good to get started with it. So GitHub Actions, it's a CI/CD tool where you can create pipelines and automate and create automation for your code that is being pushed to your repository on GitHub. The main blocks for the GitHub Actions are the runners. As I said, it's 2 types of runners. The public ones, you can use 2,000 minutes per month. It will be plenty to run all your tests. Then they have workflows. Workflows are pipelines. literally that. So a workflow is a pipeline. And then you have jobs, action, and steps. For each pipeline needs to have at least one job. And then each job will have a step with actions. That's pretty much it. I'm gonna jump here a little bit. So runners, workflow, jobs, action, steps. So when you're creating a workflow, to create a quick one. So if you guys go to our organization on GitHub, not the Academy repository, to the organization where you can see all the repositories, we now have another repository here called Playground. You all should have access, admin access to this repository, because you need more admin permissions to be able to test better your GitHub Actions pipelines. Because if we do with the Academy one, you guys will need to keep waiting for our permission to merge and push your code. So on the Playground one, you are allowed to do whatever you want to. You have permission to create codes, to push to master, to create pull requests, to merge pull requests. You don't need to wait for approval of anyone. You can overwrite and merge your code. I would just say, consider other people's work. Don't delete other people's work. I would recommend to creating a folder with your GitHub username here and do your automations inside it. Cool. This Playground. Just use this one for the exercise. For the exercise, I want you to test it here, create pull requests, make sure that the automation is working for whatever the exercise asks. And then back to the Academy one, you create a pull request and you paste all the codes that you use on the Playground to make it work. And then you can also attach a link to the pull request showing the actions running for the exercise. Cool. Going back to the Academy one. When you create to create a workflow for the GitHub Actions, you need to use that folder. So .github on the root of the repository and /workflows. So if we open here, if you guys check the Academy one, you see that we have a .github folder here, and we have a workflows folder here, and then we have a few workflows, few pipelines created. Again, back on the Playground, as you won't be able to have your own username folder, it's a single folder that all the workflows needs to be there. The name of the YAML file here can be whatever. So maybe call it your GitHub username or something like that for your workflows. So inside the workflows, you create YAML files. The syntax for the workflow, it's all YAML. And then it has a name, and then can have one or more jobs. As I said, each job has one or more steps, and each step has a command or action to do. Important thing to notice is that each job on a workflow will run entirely in one runner. So what I mean with that is, if my job one is to check syntax error on my code. No, sorry, let's try another one. So my first job is to build my application. And then I build my application and tag it. Docker build, and then tag my application. When I run my job 2 applications, this runner here will stop. I'm gonna ask to create a new runner, and the new runner will have all new files. And if I try to run an integration test, for example, that I need my application to be working, and if I do a Docker run, the name of the tag that I use it to tag on the job 1, it won't work because it was never pushed to anywhere else. And this new job, it has all new files, so it doesn't have this new tagged image. So you need to think about that. If you need to do something like that, and you need to build, tag your image, and then run it and do some tests, you probably will just do it in one job, because it's gonna use the same runner. Or how could I build my application and tag it on my job 1, how could I make it accessible for the job 2 to access that build application on the job 1? How could I do that if they are entirely new? Think about it's entirely new computer. How the new computer will know about the image that I built on the first job? Nope.
We can share that information on a bucket.
It's a Docker image. Well, where else can I share a Docker image? Yeah, I think you're in good, Matt.
The ECR, Docker Hub.
Yeah. You were saying, Heaven?
I was just thinking something that we mentioned before, using Docker Compose to run the image run the next job within a container.
But the job 2 won't have the new, because I just built the image. And then this one is a new computer with the same code checked from the GitHub. But it doesn't have the build part. But Matt answered. So I would make sure that my first job after building the image, push it to Docker Hub. And then the job 2, before doing the test, I would just pull from Docker Hub and then do the test. Or just build again. Sometimes you just do that. You just build again the image. Because here you build and you run some tests. And then here you build again and do some other tests. I don't know. It just some other ways of doing. This is how it looks like a YAML file. So a name for your workflow, your pipeline. This on here, it means is when it's going to happen, when it's going to be triggered, this pipeline or this workflow. In this case here, on pull request. So every pull request on your repository, it's going to be triggered and do this job. That's pretty much it. There is a quite extensive syntax document for this with all the options that you guys can add and change. For example, you can do on pull requests, or you can do on push code. And then you can have a branches here saying that just pushes for master or just pushes for my branch, some other branch, or pushes but exclude master to all other branches but not on master. It's a quite complex documentation, like quite extensive documentation that you guys can go through and check for.
So, sorry, Kyle, just something important is that you can have multiple workflows in the same repo. So you might want to execute a few steps on a pull request and different tasks on a push to a master branch. So you can have multiple workflows to do different things based on different events.
Yeah, you like each workflow, it's a pipeline, and you can have any numbers of pipelines and doing different actions and different things for different things that is happening on your pull request. For example, if a pull request is created for master, you do something. If someone pushes code to a branch that is not master, do something. And there you go. I'm gonna show two examples that we have here. So we actually have two workflows on our repository. One is label and another one is called stale. The label one is the one that adds the ready for review tag each time that you guys create a pull request. If you see here on the steps, there's no command, no script here. It uses this thing called use and actions. This is coming from a public marketplace of automations that the community keeps. So there is quite a few things that it's most likely that if you guys think about like, how can I make a comment on a pull request, automatic comment something on a pull request, it's most likely that we'll have a public action that already does that. And then you just have to consume here, like a plugin. And then you just need to use, this is another thing that we can do. I mentioned before, we can use secrets. So for this, action labeler to work, you actually need to use your GitHub token. The our documentation has a link to show you guys how to export your GitHub token. Take care of it as you take care of your AWS credentials as well. Anyone with your GitHub token can have access to your repositories and maybe delete your code. I don't know. It's not as dangerous as the AWS one, but still it's a secret. If you find out that you posted to your code with your code, make sure to go and delete and create a new one. So instead of hard coding the GitHub token here, we just use a secret. We call a variable and saying that it comes from GitHub secrets and it's called GitHub token. So if I go here on GitHub and then go to my username, sorry, on settings here, and I'm not gonna click and click in secrets, you see all the secrets that you have created. They pretty sure will be hidden. Not gonna click now. And then you can create your own secrets and then reference on your workflows and your pipelines as a variable instead of hard coding those values. So back to the class. And the other workflow that we have here, it's the stale. As you guys can see, this one is not running on pull request or push. It's actually a cron job. So it's another way of doing on schedule cron. This is a cron syntax. Not too sure when it's running here. I think it's midnight every day, every Monday or something like that. It runs the jobs
every day of the week.
Cool.
Every day.
Another point on this pipeline is it runs on Ubuntu. So it is actually pointing to run the action on a container, inside a container. But I'm going to go through that again really soon. And the steps is again to use existing actions from the marketplace called stale. And this one will, again, I think it's just you just tag your pull request when you guys forget about your pull. We asked you to do change, you forget about it. After 2 weeks, we go there and tag it for deletion. And then if you guys don't do anything, I think 1 more week, it gets deleted. So this is 2 types of workflow that you guys can use as an example for your exercise. Trying to rush here to finish the class. Cool. So if using the same concepts from CI/CD pipelines with workflow and pipelines with GitHub Actions, this is something that will looks like a workflow. So I have just one job. I don't need to go really complex and have multiple jobs and stuff. One job, few steps, and then it runs a few things. So it can run a build bash script. If that completes no errors, do a test bash script, and then do a publish bash script. So really simple pipeline that can go from test to publish. And then, of course, inside those scripts that will have the logic that, coming back to our examples, will run tests on your code, will build your image, will push to Docker Hub, and then the publish maybe will update your ECS to update your task definition on ECS to run the new image that you just published to ECR on Docker Hub. Hopefully you guys know what I'm talking about. You're doing the project and you know what I'm talking about. But you see, now I have something here to show you, a bit curiosity. For each CI/CD tool, a pipeline syntax, they mostly use either YAML or JSON files for the syntax of your pipeline when defining steps, actions, jobs, and all those things. That they might have different names, like GitLab pipeline doesn't have workflows, they have pipelines, but they essentially all the same. but they use different syntax for your YAML. So I got here a few examples. Those are not real, and don't try to run this code here on Circle CI, because I don't think it's going to work. But it's just to exemplify that for each type of CI/CD tool, you might have a different syntax. So for the same echo test and then running a test sh, for GitLab pipeline, you do this way. You call a script, and you have an array of commands. For GitHub Actions, you can use a pipe and then have your bash scripts, your bash commands, your shell commands. Google Cloud Build, you can do something like that. So instead of run or script, you have args, and then you can do array like that. Circle CI, so you have steps, checkout, run. So you can see that it's all different. Imagine that if for each type of CI/CD, I'm using Google Cloud Build now, and then I have plenty of scripts here saying to delete folders, to stop web server, to move files around, to build, to push emails, all sorts of scripts here. And then I need to move to GitHub Actions. Then I'll have to work out all that syntax of this YAML here again on a different tool. That's when the 3Musketeers shine. How would be what I would do here if I was using 3Musketeers instead of this? Wouldn't be something like that?
Because it's just Docker to run the scripts and everything instead of the command.
Yeah, exactly. So instead of having commands and calling scripts and everything, I'll just have a make target here. And then the make target, make test, will call my Docker compose that will run my Docker image and will do all my automation behind the scenes. And then for every time that I need to move around those different CI/CD tools in the market, I just need to move my make test run. I don't need to do any other scripting. I just keep moving my make test. And if I need one of you guys to try right now my automation, I don't need don't need to give you a full load of instructions like run this and that, have this installed on your computer. I will just say make test, and that's it. So that's when the 3Musketeers, again, it's a pattern. It's ways of doing. It doesn't mean it's right or wrong, but it helps quite a lot.
Just one question. So I understand that if you put your code inside a make, it's gonna basically create or build a Docker image and then run inside the Docker image. So then you can install whatever tool you need to run the script. So, but to build the Docker image, do you need to have Docker installed on your computer?
Yes.
So the only thing that you need is the make and the Docker application.
And the Docker compose. That's the three things that you need. Yeah. Instead of having lots of requirements, you still have requirements, but they are fixed. Make, Docker, and Docker compose.
Make, Docker, and Docker compose. Okay.
So the same workflow that we were using scripts here, we're using 3Musketeers would be make build, make test, make publish.
Just one more question. So if I use GitHub Actions, and if I put my make file there, or can I just put my make file there and run?
Cool. So that's when the run zone comes into play. So for this job here, I'm saying run zone self-hosted. So this self-hosted here will run the public runner. It's hosted. No, this one, it's for running on my own runner. So if I tell my job to use the self-hosted one, we are not going to use self-hosted for this class, but I would need to have one registered to my account, and then the workflow will just pick it up the runner that is available to actually run this code. Then of course the runner that I have on AWS running on EC2 or on your own computer will need to have make, Docker, and Docker Compose installed on it, right? So you maintain the requirements on your runner installed, and then the runner will be able to run your commands for you. Other way of doing is instead of putting the runs on self-hosted, you can use actually a container with an image, and then you can just run an image that you know that have make, Docker, and Docker Compose installed, and then we run from those public ones, from those public runners. You choose an image. If you don't have an image, if you can't find an image on the internet that has make, Docker, and Docker Compose installed, you can create your own image, push to Docker Hub, and then just reference here your image with make, Docker, Docker Compose. Some other things that we have here is the needs. So for example, I just want to run the alert step if my build completes, after my build completes. So I can create a new step, a new job in this case here. I only want to run this job, which is maybe sending an email that my build was complete if the build job was complete. Of course, I can also use environmental variables as well. So steps can have environmental variables, first name, last name. And as I showed you guys before, on settings, secrets, you can add new secrets, and then reference on your code with an env secrets.
So just one question. One way to do this could be have your variables on secrets and your other variables on like a variable file. Have your make script on like a GitHub Actions.
Yes.
And just run. So if you run, it means that it's gonna run inside a container that has everything that you need, like Docker Compose, Docker, and make.
So one type of variables that you would just use a plain file instead of using a secret would be something like environment, dev, or production. So instead of, you don't need to create a secret to put the string development or production. And then this variable you could use for pointing to which environment you are deploying the code to. So you just create a .env file and put there environment equals to production. And then here somewhere you have a point in that variable, that environmental variable from the file itself, not from secrets.
Okay.
And secrets you're going to use for passwords mainly, or anything that is sensitive. Instead of, because everything that is not a secret is going to be logged when the actions, when the workflow, when your pipeline is running. It's going to be logged on the, you will be able to see on the logs what the value of those variables was. When it's a secret, it's going to just show the name of the variable of the secret, not the value of it.
But how about like a username, password of a database inside a, for example, I have my environment, my production environment running, and I just want make a change there, and I need to pass the username, password for make a change inside the database.
Then you use the secrets.
Secrets, right? Okay.
Because when the workflow runs your script, your automation, and there is a variable that points to a secret, it's not going to show the value of that variable. It's going to show just the name of the variable, because it understands that it's a secret and it can't show that. It will use it. It will consume on the runtime. Like when the automation is running, it's going to use the value of it, but then on the logs is just going to show the name of the variable.
Okay.
And to check the workflow that you guys create, you just go to, sorry, you can go to actions. That is like the main one. You can see all the actions running in the repository. Most of them will be the labeler one that label your pull request with the ready for review. Or if you go to a specific pull request, for example, this one here from Lucas, you can see the checks and you can see logs here for the labeler workflow. So it's gonna show everything that it did. You can come here and do some troubleshooting. And as you guys see, the GitHub Actions added the ready to review label as soon as Lucas pushed the latest code. I think that's it. Let me just check. Yes. So again, as always, plenty of reference for you guys to keep doing some more research. We don't need you guys for the project to do crazy complete pipelines. If you can get a pipeline that builds your image, push to Docker Hub or ECR, and maybe a deployment that updates the task definition to ECS or deploys, if you're doing just plain EC2, just updates the image that is running. I think that would be great. You guys have any questions for that? Sorry that I had to speed up in the end. No? All good? Cool. I'm gonna finish the class for tonight then. Please, you guys only have 2 weeks to finish the project. Come to us, ask for help. We are here to help you guys. We can do a Zoom conference and help you guys complete the project. Cool. Take care, stay safe. I'll see you guys in 2 weeks. No, not 2 weeks. I hope you guys to keep asking us questions before that.
Thank you.
Any questions?